Hello my dear students, Assalamu alaikum. Today we discuss about chapter 6, Gravitation and Gravity, which is taken from physics first paper for class 12. Now we discuss about Kepler's law. There are three Kepler's law. First one, the law of ellipse. Look at the figure. This figure shows an ellipse. Every ellipse has two centers. These two centers are called focus. In this figure, here F and F prime, F and F prime are two focus. According to the law of ellipse, every planet, this is the planet, every planet rotates around an ellipse, keeping sun at one focus, anyone, either F or F prime. Now sun is located at the focus F. Let us consider the sun located at the focus F. So what is the law of ellipse? Every planet rotates around an ellipse, keeping sun at one focus. So the law of ellipse states that the orbit of each planet is an ellipse which has the sun at of its one focus, I say again, the law of ellipse, the orbit of each planet is an ellipse which has the sun at one of its focus. Now the second law of Kepler's, the law of area. Here F and F prime are two focus, sun located at one focus F. When the planet moves around an ellipse and planet reaches at this point, the distance between planet and sun is smaller. For this reason, the gravitational attraction force on planet by the sun is greater in this region. In this region, the distance between planet and sun is smaller. For this reason, the gravitational attraction force on planet by the sun is greater. When the planet moves and reaches in this region, the distance between planet and sun is greater. For this reason, the gravitational attraction force on planet by the sun is smaller. So when the planet moves around an ellipse, in this region the gravitational attraction force will be greater. In this region the gravitational attraction force on planet by the sun will be smaller. This gravitational attraction force created centripetal force. This centripetal force act towards the focus. This centripetal force act towards the sun. Now we know that the equation of centripetal force Fc equal mb square by r. In this equation, if centripetal force is greater, the velocity will be greater. If centripetal force is smaller, the velocity will be smaller. So look at the figure. In this region, the gravitational attraction force on planet by the sun will be greater. For this reason, the centripetal force on planet will be greater. For this reason, the planet move fast in this region. In this region, the planet move fast. On the other side, the gravitational attraction force on planet by the sun will be smaller. For this reason, the centripetal force also is smaller. For this reason, the velocity the velocity of planet will be smaller. In this region, the planet moves slowly. In t time, in this region, in t time, the planet moves from A to B. In t time, the planet moves from A to B. In the same time, in this region, the planet moves from C to D. In this region, the distance will be greater because centripetal force will be greater. For this reason, the velocity will be greater. In this region, the distance will be smaller. The distance in t time will be smaller because the centripetal force will be smaller. For this reason, the velocity also is smaller. Now, according to the law of area, the area covered by the joining line between planet and sun in equal time is equal. In equal time is equal. The covered area by the joining line between planet and sun in equal time is equal. Now, at the point A, the joining line AF. At the point B, the joining line BF. The area covered by the joining line between planet and sun. The area covered by the joining line, this is the joining line and this is the joining line. The area covered by the joining line between planet and sun is AFB. On the other side, at the same time t, at the point C, the joining line CF. The joining line between planet and sun is CF. At the point D, the joining line between planet and sun FD. Now, the area covered in t time in this region is CFD. If the time t, this time t are equal, then the area AFB and the area CFD are equal. If the time are equal, so area AFB equal area CFD. Both are equal if the time are equal. Now, the law of area states that the covered area by the joining line between planet and sun in equal time is equal. Now, Kepler's third law, the law of time period. When the planet moves around an ellipse and the planet reaches at this point, the distance between planet and sun will be minimum. And let us consider the minimum distance will be r1. When the planet moves around an ellipse and reach at this point, the distance between planet and sun will be maximum. Let us consider the maximum distance will be r2. That means the distance between planet and sun are not equal. Now, we count the average distance between planet and sun. Here the minimum distance r1 and the maximum distance r2. Now, average distance between planet and sun will be r1 plus r2 divided by 2. This is the average distance, and average distance we denote the letter r. So r is the average distance. R is the average distance. Look at the figure. This figure shows this is the planet 1, and this is the orbit of planet 1. This is the planet 2, and this is the orbit of planet 2. Now for planet 1, the average distance between planet and sun, the average distance between planet and sun will be minimum. For this reason, the time period of planet 1 will be smaller. The time period of planet 1 will be smaller. Now for second planet, the average distance between planet and sun will be greater. For this reason, the time period of planet 2 will be greater. So in planet 1, the time period will be smaller. For planet 2, the time period will be greater. If the average distance between planet and sun will be increases, that's why the time period will be increases. Now according to the law of time period, the square of the time period is directly proportional to the average distance cube of the average distance between planet and sun. Now again, the law of time period is state that the square of the time period is directly proportional to the cube of the average distance between planet and sun. Now t square is directly proportional to r cube. Now t square equal k r cube. K is the constant, proportionally constant. Now for planet 1, the time period, let us consider for planet 1, the time period will be t1 and the average distance will be r1. For planet 2, the time period will be t2 and the average distance r2. Now we write this equation for planet 1 and planet 2. For planet 1, this equation will be t1 square equal k r1 cube. And for planet 2, t2 square equal k r2 cube. Now this is the equation 1 and this is the equation 2. Now equation 1 is divided by equation 2. Now equation 1 divided by equation 2. t1 square divided by t2 square equal k r1 cube divided by k r2 cube. K and k cancel. Now the equation will be t1 square by t2 square equal r1 cube divided by r2 cube. This is the formula of Kepler's third law. T1 is the time period of planet 1 and r1 is the average distance between planet and sun for planet 1, and t2 is the time period of planet 2, and r2 is the average distance between planet and sun for planet 2. Now what is the law of time period? The law of time period states that the square of the time period is directly proportional to the cube of the average distance between planet and sun. Now let's solve the problem by using Kepler's third law. This is the problem. radius of the planet Mars is 1.53 times the radius of the Earth. If 365 days in Earth makes 1 year, then in how many days a year will be in Mars? Now, let us consider the radius of the planet Mars is Rm. Let us consider the radius of the Mars planet will be Rm and the radius of the Earth will be Re. So that the condition of the question Rm equal 1.53 Re. Then Rm divided by Re equal 1.53. Now from Kepler's third law, here in this question, the time period of Earth is 365 days. Now let us consider the time period of Earth will be TE equal 365 days. Now from Kepler's third law, we know that the Kepler's third law, Tm square divided by Te square equal Rm cube divided by Re cube. Now Tm square divided by Te square equal Rm divided by Re whole cube. Now putting the value of Rm by Re, the ratio of Rm and Re will be 1.53 and the value of Te will be 365 days. Putting the value in this equation and we will find the value of Tm. Now Tm square equal 365 square equal the ratio of Rm and Re will be 1.53 whole cube. Now the value of Tm is 691 days. So everybody calculate it. Now we discuss about gravitation, gravity and weight. What is gravitation? The attraction force between two objects in the universe. The attraction force between two objects in the universe is called gravitation. Now we consider the object of mass m1, another object of mass m2, and the distance between two objects is d. From Newton's gravitational law, the attraction force between two objects is F equal G m1 m2 divided by d square. This is the Newton's law of gravitation. This is the attraction force between two objects. Now, what is gravity? Gravity means the gravitational attraction force on an object by the earth. The attraction force on an object by the earth is called gravity. That means gravity F equal mass into gravitational acceleration. Gravity F equal mass of the object and gravitational acceleration. This is the gravity. And what is the weight? Weight and gravity are equal. Weight and gravity are equal. Weight means the attraction force on an object by the earth is called weight. That means weight and gravity are equal, so that weight W equal mass into gravitational acceleration. Now, what is gravitational acceleration? Gravitational acceleration means when the object falling down freely, this is the ground surface, and when the object falling down, when the object moving downwards freely, the rate of change of velocity for a falling body is called gravitational acceleration. The rate of change of velocity for a falling body is called gravitational acceleration. Now we will find the gravitational acceleration on the earth surface. Gravitational acceleration on the earth surface. Now look at the figure. This is the earth, and the total mass of the earth act at the center of the earth. Total mass of the earth is located at the center of the earth, and the radius of the earth will be r. Now let us consider an object of mass small m is on the earth's surface. Let us consider an object of mass small m is on the earth's surface, and also let us consider the gravitational acceleration at the earth's surface will be g. Let us consider the gravitational acceleration at the earth's surface will be g. Now from Newton's law of gravitation, this is the object, this is the mass of the object, and this is the mass of the earth, and the distance between object and the center of the earth will be r. The distance between object and the center of the earth will be r. Now according to the law of gravitation, from Newton's law of gravitation, the gravitational attraction force between object and earth will be F equal G capital M small m divided by r square. This is the gravitational attraction force between earth and object. Now from gravity means the attraction force on an object by the earth is called gravity. Gravity and weight are equal, so that gravity and weight, now gravity or weight, W equal mass of the object and the gravitational acceleration at that point. Weight equal mass of the object and gravitational acceleration at that point. So this is the equation 2. Equation 1 also represent the attraction force between object and earth. Equation 2 also represent the attraction force between object and earth. So both are equal. Equation 2 equal equation 1. Now equation 2 equal equation 1. Now W equal F. W equal F. So that W equal small m into small g equal F means G capital M small m divided by R square. Small m both sides cancel out, so that small g equal capital G capital M divided by R square. Then small g equal G capital M divided by R square. This is the equation will be used to find the gravitational acceleration at the surface of the earth. This is the equation. In this equation, capital M is the mass of the earth, R is the radius of the earth, and capital G is the gravitational constant. The value of gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square kg inverse 2. Similarly, we can find out the gravitational acceleration at the surface of any planet. at the surface of any planet by using this equation. For example, this is the Mars planet. This is the Mars planet, and the total mass of the Mars located at the center of the Mars, and the radius of the Mars will be r, so that the gravitational acceleration at the surface of the Mars g equal g capital M divided by r square. In this equation, m is the mass of the Mars planet and r will be the radius of the Mars planet. Okay, thanks to all. And next lecture we will discuss about the gravitational acceleration at a certain height from the Earth's surface or at a certain depth from the Earth's surface. Okay, Allah Hafiz.